This is Unit 6, Chemical Reactions. Chemical Reaction Cheat Sheet. These are the symbols that are used in chemical reactions. S stands for solid, L, liquid, G, gas, AQ stands for aqueous or dissolved in water. An up arrow can also indicate a gas. A down arrow is a solid. The plus sign is used to separate reactants or products. This is an example of a chemical equation. H2H2 plus O2 yields 2H2O. The arrow means yields. If there is an arrow going both directions, this means that the reaction is reversible. An arrow with an element or a compound on the top means that there is a catalyst. An arrow with a triangle means that heat is added to the reaction. Reactants are on the left side of the equations, and products are on the right. Remember diatomic elements. So when you're writing chemical equations, it's important to remember that there are 7 diatomic elements. These always exist in pairs. So they are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Or, remember, the scientist Brinkelhoff. So determine the formula and the state of the following reactants. Chlorine gas, it's always in pairs, and it's a gas. Neodymium, oxygen, is also one of the diatomics. The symbol for gas is a G. Finish the other 3 on your own. The law of conservation of mass. Antoine Lavoisier was a French chemist. He was born in 1743 in Paris, France, and was executed during the French Revolutionary War. Lavoisier burned a sample of wood and oxygen in a sealed container to prove that mass was not lost in a chemical reaction. This concept, mass is not created or destroyed in chemical reactions, became known as the law of conservation of mass. So the mass of all reactants must be equal to the mass of all the products. To show that mass is conserved in chemical reactions, equations must be balanced. To balance a chemical equation, you use coefficients. These are the numbers that come before the chemical formula. So coefficients are the big numbers, subscripts are the small numbers inside of the formula. Subscripts tell you how many atoms you have of one element. Coefficients tell you the number of moles of that compound. Coefficients multiply all of the elements in a compound by a whole number. So determine the number of each element on both the reactant and product side using these balanced equations. So magnesium, there's 1. Hydrogen, there are 2 because of the coefficient. And chlorine, there are 2. On the product side, we have 1 magnesium. The subscript tells us that there are 2 chlorines and 2 hydrogen. For the next reaction, on the reactant side, there are 4 phosphorus because of the coefficient, and our coefficient times our subscripts gives us the number of oxygen. So we have 10. On the other side, there are 4 phosphorus and 10 oxygen. So what is a chemical equation? Chemical equations show the amounts and the types of atoms that are involved in chemical reactions. What does it mean to be balanced? Balanced means that the number of atoms of each type must be the same on both the product and reactant side. Here are your instructions for balancing equations. Why do they need to be balanced? So in 1774, French chemist Antoine Lavoisier burned wood and oxygen in a sealed container. This was the law of conservation of mass. Mass is not created or destroyed in chemical reactions. This law is why equations must be balanced. So we balance them using coefficients. Coefficients are the whole numbers in front of the chemical formulas. They always must be whole numbers greater than 1. If there isn't a whole number in front of the chemical formula, it is understood that the coefficient is 1. So balance the following equations. Over here, we have 2 Cl's. On this side, there's only 1. So we need a coefficient of 2 on this side. That makes 2 hydrogens. So we need a 2 over here. That also made 2 bromines, but now that that's balanced. On the second one, we have 8 sulfur and 2 oxygen. Over here we have 4 sulfur. So we need a 2 here. That'll give us 8 sulfur. And oxygen is now 12. So on this side, we need a 6. Types of chemical reactions. A chemical reaction is the process by which atoms are rearranged to form new substances. Chemical reactions are chemical changes. There may be a chemical change if you observed heat or change in temperature, bubbles or the production of a gas, a color change, or the formation of a precipitate, so a solid formed by mixing 2 liquids. Determine if the following are chemical or physical changes. Yellow food dye is added to a blue solution. The solution turns green. That's a physical change. A clear colorless solution is mixed with a second clear colorless solution. The mixture becomes cloudy, and a yellow powder settles at the bottom of the test tube. That would be a chemical change. A clear colorless solution is poured over a metal. A brown solid forms around the metal. That's a chemical change. Acetic acid is added to a white powder. This causes fizzing and becomes cool to the touch. That would also be a chemical change. And a small amount of liquid silver is added to water, causing the water to heat and gas bubbles to form. This is a physical reaction because you're heating the water. Chemical equations. What are chemical equations? Chemical equations use symbols and numbers to represent the chemical changes which occur in the real world. Again, the left side of the equation is the reactants. The right side is the products. The small numbers inside of the formula are subscripts. The arrow means yields, and the large numbers in front of the formulas are the coefficients. In an equation, the reactants are consumed in order to create the products. Coefficients are used to indicate the mole ratios between the substances. We'll talk a lot more about moles in January. It acts like a sort of chemical recipe. The arrow means yields, makes, or produces. An triangle over the yield sign means that heat was added to the reaction. In equations, coefficients equal moles. Write an equation from the word equation. 1 mole of zinc reacts with 2 moles of HCl to form 1 mole of zinc chloride and 1 mole of hydrogen. So this tells us our balance numbers, or our coefficients. So zinc reacts with, means plus, 2 HCl to form 1 mole of zinc chloride plus 1 mole of hydrogen. Remember that hydrogen is a diatomic element. So use this equation to answer the questions. What are the products in this reaction? Those are CO2 and water. What substances are being consumed? So what are the reactants? C7H2 and O2. What states are the substances in this reaction? So those are liquids and gases. So types of reactions. The first type is a synthesis reaction. In synthesis reactions, 2 reactants combine to form 1 product. When 2 elements react, it is always a synthesis reaction. So you should look for multiple reactants and only 1 product. The general form of this equation is A plus B yields AB. Decomposition is the opposite of synthesis. One reactant decomposes into two or more products. So look for one reactant and two or more products. The general equation is A yields B plus C. Single replacement. In a single replacement reaction, one element will switch places with an element in the compound. Either the two cations will switch or the two anions will switch. A cation will never switch with an anion. Check the activity series to see if a reaction takes place. So look for a single element and a compound in the reactants. The general equation is A plus BC yields B plus AC. In double replacement reactions, the anions switch partners. So you're going to look for a compound and a compound in the reactants. The general equation is AB plus BCD yields AD plus CB. In a combustion reaction, oxygen combines with a reactant and produces CO2 and water. Oxygen is always going to be a reactant. So look for a CH compound or a hydrocarbon plus oxygen or a pure element in oxygen. If you have a pure element in oxygen, this is also a synthesis reaction. Acid-base neutralization. Acid-base neutralization reactions is a special type of double replacement. The products will always be water and salt. Precipitation. In a precipitation reaction where two aqueous solutions are mixed and an insoluble solid is formed. A redox reaction, or an oxidation-reduction reaction, changes the oxidation state of the atom. The oxidation is the loss of electrons. The atom becomes more positive. Reduction is the gain of electrons. It becomes more negative. So identify the types of reaction as synthesis, decomposition, single replacement, double replacement, or combustion. The first one is synthesis. The next one, we have two reactants and only one product. So that's synthesis. On the third one, oxygen is one of the reactants, so it is combustion. In the fourth one, we have one reactant and it's breaking apart. That's decomposition. Pause the video and answer the rest of the questions, then check your answers. Predicting products with synthesis. So the common patterns, if you have a pure element and another pure element, you'll make a binary compound, like sodium plus chlorine yields NaCl. A metal oxide, like potassium oxide, plus water will yield a metal hydroxide. A metal oxide plus carbon dioxide will yield a metal carbonate, so CO3. A metal plus just oxygen, which is also a combustion reaction, will yield a metal oxide. A nonmetal oxide plus water yields an acid with one more oxygen than what was in the nonmetal oxide. So predict the products for the following synthesis reaction. The first one, you have an element plus an element. So this is going to give you a binary ionic compound. The next one, you have aluminum plus an oxide. So our product will be a metal oxide. We still have to balance the charges. So we would have Al2O3. Number 3, you have a nonmetal oxide plus water. So we have an acid with one more oxygen. Okay, the next one you have a carbonate. You have CO2, so this is going to form a carbonate. So we have calcium carbonate. Decomposition. So this is the opposite of synthesis. A binary compound will break down into a pure element and another pure element. A metal carbonate will produce a metal oxide plus carbon dioxide. And a metal hydroxide will produce a metal oxide and water. So a carbonate, one of the products is going to be CO2. The other is a metal oxide. So NaO. We have another carbonate. So one of the products is CO2. The other one is an oxide. Number 3, we have a metal hydroxide. So again, we'll have a metal oxide plus water. Number 4, we have a binary compound. So those will just split apart. Remember that bromine is one of the diatomic elements, so it's always going to be found in pairs. Remember, those are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. The next two are also binary compounds, so write the products. A single replacement reaction happens when an element trades places with an element in a compound. Nonmetals will only trade with other nonmetals. Metals will only trade with metals. Determine if an element is a metal or a nonmetal. Then determine which elements in the compound it'll switch with. So looking at the quick check, Ba is the pure element, and it is a metal. So it's going to switch with the other metal. Lithium is also a metal. It would switch with the metal in iron chloride. For here you have a pure element is chlorine. It's a nonmetal, so it'll switch with the other nonmetal. Single replacement reactions do not always occur. They only take place if the pure element is more active than the element it is replacing. To determine if a reaction will take place, look at the activity series for metals or nonmetals. Double replacement. In double replacement reactions, the anions switch partners. You do not have to look at the activity series for double replacements. These typically happen in aqueous solutions. Precipitation reactions are a special type of double replacement. These occur when two aqueous solutions react and one of the products is insoluble. This will appear as the solution getting cloudy or as a solid that falls to the bottom of the container. So determine the products for the reactions below and circle the insoluble products. So our anions are going to switch partners. So aluminum would now be with NO3, and silver would be with chlorine. So if we look at the solubility chart, we see that most chlorides are soluble, but silver chloride is an exception. So it would be a solid. Next one, we have sodium carbonate and calcium hydroxide. So they switch partners. So we have sodium hydroxide and calcium carbonate. Carbonates are generally insoluble. Answer the last one on your own. In combustion reactions, hydrocarbons or pure elements react with oxygen and release heat. The products of a hydrocarbon combustion, that is a compound that contains only hydrogen and carbon, will always be CO2 and water. The products of a pure element will always be an oxide. So determine the products. This is the combustion of a hydrocarbon, so our products are CO2 and water. When magnesium reacts with oxygen, it'll form metal oxide, so magnesium oxide. And the third one, this is also a hydrocarbon, so the products are CO2 and water. Quick check. Determine the type of reaction: synthesis, decomposition, single replacement, double replacement, or combustion. Then predict the products. So the first one is decomposition. Since it's a chlorate, it will break down into an oxygen and KCl. The next one is single replacement. Magnesium will switch places with hydrogen. Be sure to check the activity series to make sure the reaction occurs. We see that it does, and the products are magnesium chloride and hydrogen. Reaction 3 is synthesis. Sodium plus hydrogen would yield NH3. The next one is combustion. Since that's a hydrocarbon, the products are always going to be CO2 and water. And the last one, we have magnesium iodide and calcium bromide. This is a double replacement reaction, so the ions are going to switch partners. This is a flow chart to help you predict products. Determine which type of reaction you have, and then use the flow chart to find out what the products would be.